Hi everyone, I wanted to do a quick video to show how easy it is to serve HTML files from the ESP32 from SPIFFS. So in this video we're going to show how to control an LED using an HTTP endpoint. We'll build a very simple user interface using some basic HTML and JavaScript. And then I'll show you how to serve that UI directly from the ESP32 using SPIFFS. So I'm going to be using PlatformIO for this project because it makes uploading SPIFFS very simple. So let's jump into PlatformIO and create a new project. So I've started PlatformIO. Let's create a new project. So we'll just call this web server demo. And for the board, we'll use an ESP32. And we just use the dev module. And we use the Arduino framework. So in PlatformIO, your source files are under source, so it's given us a default main file. Now we're going to be using the async web server, so if we click on the PlatformIO logo and then go to libraries, then we can search for async. And here we have the ESP async web server. So I have this installed already. So let's go to our code and actually create a web server. So the first thing we need to do is include the header file. And we'll also use MDNS so that our device is easy to find. And we'll use JSON for sending messages to our device. And I'll create a Wi-Fi credentials file for my Wi-Fi settings. So I'll do that file now. So I'll just go to Files, Source, New File. And I'll do some hash defines in here. For my SSID and password. So now we can create our web server. So we just do async web server, and you specify the port that you want to use. So port 80 is the default port for HTTP. So now we can begin our setup code. So we'll set up the serial port first, just so we can show debugging information. And then we'll start up Wi-Fi. So now we're connected to Wi-Fi, we can set up the MDNS. So this will give our device the name demoserver.local. Now I want to control the LED, so on an ESP dev board that's pin 32, pin 2. So we'll just do a quick hash define for that, and we'll set our pin mode to output. Now, while we're developing our user interface, we'll want to run the UI locally in Chrome and talk to our device remotely. So what you'll find when you try and do that is you hit problems with something called cores. So what we need to do is add some headers to our server so that Chrome allows our local UI to talk to our remote UI. So the easiest way to do that is to add some default headers to our server. So these headers basically allow access to our device from any website using these methods and with any headers. So now we've done that, we can actually build the endpoint to control our LED. So we'll use server add handler. We'll have a async callback JSON web handler. So this will allow us to send JSON to this endpoint, and we'll create an endpoint called LED. So this endpoint will take a JSON payload and we'll pull out data from that. And what I will do is I'll just pass a simple JSON object with an on parameter. So that's our handler done for turning an LED on and off. So now we just need to add a handler for the not found endpoint and for the options endpoint. Now the options endpoint is very important because when the web browser tries to see if it can access this endpoint, it will first do an options request to check the access control headers. So let's add a server on not found. And if it's an options request, we'll just send an OK response. So 200 is HTTP OK. Otherwise, we'll actually send a 404. So a 404 response is not found. So that's our basic sketch. That's actually all you need to do to have a running web server. So they don't need to put anything in the loop. That's all handled by the async web server. So what should happen is when a request comes on the LED endpoint, we'll pass the JSON body. If it contains an on parameter, we turn the LED on. If it contains an off parameter, we turn the LED off. The last part we need to do is to actually start the server. So we do server begin. So let's download this to our ESP32 and see if it works. So we'll upload to our board. So that's our sketch uploaded. Let's switch into an HTTP client and see if we can control the LED. So I've got an application called pour running here. So I've created a put, and we'll go to demoserver.local LED, and I'm going to send a JSON payload containing on equals true. So let's send that request to our ESP32 and see if the LED lights up. So we've got a 404 error, so it's not quite worked. And normally this is because we need to set the content type to application JSON. So let's try that again and see if it works. And our LED is on. But you can see this error, socket closed by remote peer. So what I've forgotten to do is actually send a response back to the client. So let's do that now. So we'll just send a 200 and we'll just say OK. So let's push that up. But you can see the LED turned on, so we're half successful. So our sketch is downloaded. We'll go back to pour. Let's try turning the LED on again. So that now works. We have a 200 and our content type is OK. Look at the message we got back. Looks fine. So I think that's successful. So let's try turning the LED off. So our LED is off. And let's try turning our LED on again. And our LED is on. So that's working quite nicely, but obviously using this as our UI is not quite where we want to be. So let's create a nice simple HTML UI. So with SPIFFS, the way PlatformIO works is you have a data folder, and any files in this data folder can be packaged up and pushed onto the SPIFFS storage on the device. So let's create a basic HTML file. To control our LED. So we'll just have a button, an on click handler, and then we need some JavaScript. And then we'll just send a request to our demo server. To the LED endpoint. And our method will be a put method. Our body will be some JSON. And that will take an on parameter with the value of our LED variable. And we need our headers. So that should do our very simple user interface. We'll make this an async function in JavaScript, so we await on the fetch. And that should do it. So let's run this up locally and see if it actually works. So I have a plugin for VS Code called Go Live, which will launch Chrome with my application here. So let's see if this works. So no obvious signs of the LED turning off and on. So if we look in our Chrome console, you can see it's struggling to find our name. So let's try that again. And looking at this, I can see I missed off the .local on my demo server. So let's fix that. So let's try again. We'll dock this in the actual Chrome display. So LED off, LED on. So that's our nice basic UI working. But obviously this is being served from my local machine, not from our demo server. So back in PlatformIO, we now want to upload the contents of this data folder to SPIFFS, and we want to set up our server to serve files from these SPIFFS. So this is pretty easy to set up. So we need to include SPIFFS. Then we need to actually initialize SPIFFS. So we do SPIFFS begin. Now, to actually serve content from SPIFFS, it's as simple as doing server serve static SPIFFS, and we'll set our default file to index.html. So let's upload that sketch again. So that's now done. If we switch back into Chrome, we can now go to our demo server.local, and we'll see our UI is now being served from demo server. So now we can switch on and off the LED. So what's really nice about this is our device is now completely self-contained. You can download its UI directly from it and control it from that UI. The last thing I want to demonstrate is serving compressed content directly from our SPIFFS. So one of the things that you might be thinking is, how much space is this user interface going to take up? So at the moment, we have a very simple HTML file. But if you start building more complex user interfaces, these files can easily start to get quite large. So let's simulate a large file just by putting in some dummy content. So we'll put in the classic lorem ipsum, and we'll just get a lot of text. So let's just copy and paste this. And put that into our HTML file. So if we now look in terminal, you can see our index HTML is now around 79K. So you'll easily start to get quite large amounts of data if you're not careful. But what we can do is we can compress our files, so we can use gzip, and now you'll see our files shrunk down to just 21K. So I can upload this straight to SPIFFS again. So we go to Tasks, PlatformIO, Upload File System Image. So that's pushed our file up again. If we go back into Chrome and we reload, you can now see we have all of our dummy text. But if you look at what actually came down over the wire, then you can see that we actually received some gzipped content and it was only 21K. So it handles the compression completely seamlessly. So that's it for this video. The only downside of compressing the content is that you now can't edit it. So you need to go back into your terminal and do gunzip. And now we can edit the file and then we can re-zip it once we've finished editing. But that's it. So you can see how easy it is to actually set up a web server on your ESP32 device, and how easy it is to build a nice simple UI and upload it to your device and serve it from SPIFFS. So I hope you found this video useful and interesting. All the source code is on GitHub. The link for that's in the description. Please hit subscribe. There'll be more videos coming, and it's the best way to get notified when they become available. Thanks for watching.